Python, and we will get started with Python by how to install, and then just play with numbers and playing with various interfaces available in Python. So before that, why Python? To answer the simple question, if you see most of the data scientists around you, the software that they would be primarily using would be Python, maybe R. Some of them might be using Scala, but you could see that Python dominates the environment. So why Python? It might be because Python is an open source software. Also, Python has a really good community support. You could see so many packages having so many discussion forums going around. It's being well documented, such as packages such as scikit-learn or numpy or pandas. So many other packages coming up in Python as well. A few years ago, you had Google launching this package called TensorFlow. They made this available to all public. Also, it's very much in demand, right? Because you could see since most data scientists and other computer scientists use this, so it's kind of is in demand. Also, the syntax in Python is really easy. So they say if you know English, you know Python. So that's how the syntax is so simple to learn. Okay, so now let's get started with how to install Python. So the version or the interface that I'm going to recommend is the Anaconda Python. So you just go to google.com and type in Anaconda Python. So you could see this particular link. You just click it. Here you go. Just go to download Anaconda. So here, whether you're using a Windows or the Mac or Linux, whichever version, I just use a Linux machine. So here we have Python 3.6 and Python 2.7. So which version to use? I would recommend going with Python version 3. This is because though Python 2.7 is being widely used currently, we are kind of in a transition between Python 2 to Python 3. So maybe later in 2 to 3 years or in some time, you could see most of the companies or most of the universities using Python 3, not Python 2. So given that as a factor, I would recommend going with Python 3. Of course, Python 3, it's kind of the latest version, so it has much more better features compared to Python 2 as well. So once we start working with Python, I would just explain why 3 works better in these particular situations compared to 2, all those kind of steps. So just go and click the download button and then save it. So you could see I already have a few downloads here. So once you just save it, so you can see it's downloading. So once it's downloaded, just click it and install. It's going to be quite simple. Okay, so once you install it, you could just open the Anaconda Navigator. So this is the interface that you would get. So with respect to Python, there are 4 ways that you could interact or write your code. The first one would be this particular spider. It's kind of called as the, just a minute, let me open this. Oh, I already have one open here. So this is how the spider looks. So you have 2 interfaces. One on the left, you could see this one, right? Kind of like a notepad file where you type in your code and store it in a .py file and then run it through command prompt or through the run button above. Okay. The other one is the interactive mode right here. Okay, on the right hand side. So this is kind of something when you type in, you get the results instantaneously. Let's say, for example, let me just add 2 numbers. Okay, so 12 plus 9. So I just did 12 plus 9, and then in order for me to get the results, I need to save this file, right? So let me just quickly save this. Education. So I just do test.py. Okay, so this is how I need to be running this particular program, right? So you can see I just did 12 plus 9. I saved the file and then I open the command prompt and then I just ran it. Okay, I got the result. So the other way to run this would be just type in here. Okay, just few. Okay, so you can see the result appearing right here. Okay, so this is how the scripting mode works. So this is used when you want to write a large piece of a code, complex piece of code for production or something. You write it there as a script, save it, and then like run it whenever required. The interactive mode is kind of like an instantaneous, like let me do the same thing right here. I just do 12 plus 9, and it just directly throws me the result 21 without even saving or like running through command prompt, etc., etc. Okay, this is how the interactive mode works. So it's kind of like so easy to, like, if you want to quickly test a particular piece of code or you want to quickly see what output you get it, so you could just use the interactive mode for the benefit. Okay, so this is the difference between the interactive mode and the scripting mode. And apart from that, like, there are various features with the uh, Anaconda Navigator, like the spider. So all basic stuff so that you would come across all software, like the file, edit, search, source, run. I think it's so easy. You have a documentation as well, which you could refer. But I would say it's kind of like self-explanatory. As you explore it, you will just learn it. Okay. So the other way would be like just accessing through a command prompt or terminal in case of Ubuntu. So you just go to your terminal and then like type Python. So you can see now it has opened the Python interface here. So we just installed like Anaconda Navigator, right? So you could see like Python, the version that we installed, and then like the Anaconda, okay, the UI that we prefer, and then like the same thing that you could just do right here. Okay. So this is another way of accessing your Python. So the final way that I want to say is my most favorite one, the IPython or Jupyter Notebook one. So what you just do is like open your command prompt and just type Jupyter Notebook. Okay, so just type and so now we just have a kind of like a web-based interface which just opens in your browser, and then like you could just come here, either upload an existing IPython notebook if you have one, or else you could just create a new one. You just go new Python 3, and then at the top you could see the name untitled, so you could just edit it. And to change the name of the file, I just do like Python, just do Python week 1. Okay, so this is the IPython notebook interface. So what you see right here is called as a cell. Okay, so cell is where you type in your code and then you get your result. So the special thing about IPython is like I just do the same thing and then I run it, you just get the output. Okay, so it's kind of like an intermediate or a mixture of both the scripting mode and the interactive mode. Okay, so the output, like the input that you enter, as you see, as you just saw, like we just got the output like an instantaneous, like the interactive mode. At the same time, you could just write complex code as well, like uh, so this is just a simple function which we would see later during this course. But the same thing, you could write it in an interactive mode as well, but it's much more easier. You could generate reports through your IPython or Jupyter notebook. Also, like, there are special commands known as the magic commands, in which like you could enter like JavaScript, SQL, HTML commands as well through IPython notebook. Okay, so let's just go through each one of them. So before going into the futures of IPython notebook, I just want to introduce you to the basics of Python, so that like we could see the futures of IPython later during this video, so that it makes much more sense for you guys as well. Okay, so going ahead. So let's start with Python. So introduction to Python. So in Python, the first thing that you need to remember is it's an object-oriented programming, and everything that you see in Python is an object. Okay. So let's say, for example, let me just erase this. So let's say one. Okay. One is an object of class int. Okay. So you could see like one is an object associated with integers. So that's how you see it's like 4.5 is an object associated with class float. Apple is a string associated with class in string. Okay, so each and everything, even functions or class, functions or list or tuples, whatever you generate through Python, it's always going to be an object. So these objects can be classified into two types, scalar and non-scalar. Okay, scalar objects are the one that can't be further subdivided. Let's say, for example, an integer, 5. You can't subdivide 5 into further types, right? 5 is just 5. 5 is integer. It ends there, right? 4.5 is float. It ends there. You can't take it down, right? But there are objects where you could just kind of like and dig it into further, can be subdivided. Let's say, for example, a list. Okay, so list is just kind of like a sequence of number. So you can just see here, I just have a list here, which has like 5 items: 1, 2, 3, apple, and 33.3. So here the first three things are integer. The fourth one is a apple is a string, and the final one is a float, right? So this can be further subdivided into several types, right? So these are called as non-scalar objects. So examples of non-scalar object would be list, tuple. Okay, so don't confuse list with arrays. Okay, arrays, we will see the difference like when we see about numpy array during later this course in much detail. But array, you could just have elements of only one type, okay, not several types. So in list you could have elements of several types. Okay, we'll just go through these details like when we see about list and numpy arrays. So getting back to Python objects, so this is the basic thing that you should know about Python objects. Okay, scalar and non-scalar. With Let's get started with the scalar one. Okay, so I'll just do this. So now, as you just saw what I did, I just created the heading scalar, okay, in IPython notebook. So this is done through something called as like markdown. So markdown is kind of like, as you would know, like markdown is kind of like a special type of syntax or a kind of like a coding style. I don't know exactly how to phrase it. So which helps you to uh, generate outputs, those kind of stuff. So you could just type in like markdown tutorial or something in order to have a better understanding of it. Okay, so you could just kind of like insert images here, like create like sophisticated headings, making particular words in bold, all those kind of stuffs in markdown. Just like the markdown that you see here, the same syntax applies here. But when you have a cell type of markdown, it's not going to work as a Python code, it's going to work as a markdown. Okay, so there are other types as well, like raw nb convert, which is just kind of like a uh, or kind of like entering a raw text. So a heading is something like okay, so you just type in hash, and then following that, whatever you type is going to be an heading. So you could just have like a heading from 1 hash to 6 hashes, just like HTML, h1 to h6. Okay, the same thing. So I'll just show you that quickly. So one scalar, you could see like it's much more bigger, right? So if I just make this hash appear twice, so you could see like the heading appear smaller, thrice smaller, 4 smaller, 5 smaller, 6 smaller. It doesn't go beyond 6. Okay, so maximum of 6 is possible. So let me just do 2 here. Okay, this is also like you could have like a better explanation here if you want. Just do scalar objects in Python. Okay, so quite simple. This is another added feature of IPython. Okay, we will just see the special feature of IPython as we just proceed through this video. So let's get started with numbers. Okay, so 1 plus 3. Okay, just basic mathematics. Okay, through operations such as addition, subtraction, multiplication, division. We'll just go through these kind of steps. Okay, it's quite obvious. I know it's quite simple, but I just want to run over these through quickly. So I think so far so good, right? So I think you all know this addition, subtraction, multiplication, division. So there is something next. What we will see is something called as like a float division. Let's say, for example, if I do 7 divided by 3, so it's 2.3333. But if I do 7 double slash 3, it's just going to be 2. This is because this is what we call as a float division. So the decimal point is being rounded off to the mm, lowest value, nearest lowest possible value. If it's 2.3, it's going to be 2. If it's 2.7, it's again going to be 2. Okay, so that's how the float division works. Um, Other things would be, let's say, for example, if you want to kind of like do a complicated operation, like, okay, this is how you could just keep on adding your objects and the operator that you want. Also, like the next thing that we might be interested is the precedence. Okay, so let's say, for example, we have division and multiplication together. So which one is going to be evaluated first? Obviously, the precedence is same as that you have studied in your high school or in your undergrad. Okay, so parentheses works first, and then the exponential comes in. Oh, I'll just show you how exponential works in Python. So most of you would have kind of like seen this syntax somewhere else. 2 power 3 is this. Okay, but it doesn't work in Python this way. It's kind of like something else. Okay, so it isn't exponential. Exponential works by double asterisk. Okay, 2 double asterisk 3 means 2 raised to the power 3, which is going to be 8. Okay, don't confuse the caret symbol with the exponential symbol. Okay, so coming back to the precedence, okay, parenthesis exponential, and then you have like division, multiplication, addition, subtraction. So, but the thing here is like when you have division and multiplication together, it goes from left to right. Okay, it's not like division is going to be executed first and then multiplication. If you have like, let me show you an example. So 8 multiplied by 7 divided by 5. Okay, it gives us an answer of 11.1. This is because 8 multiplied by 7 is 56, divided by 5 is 11.2. Sorry, okay. So if I just do this way, okay, 8 divided by 7 multiplied by 5. So the thing is that, let's say for example, okay, let me just execute this. So you could see like the answer that we get is 5.7142 dot 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 dot. Okay, this is because you could see like the division has been executed first, and then this particular value has been multiplied with 5. Okay, not the other way around. The same here. 7 divided by 5 hasn't happened here first. Okay, 8 multiplied by 7 happens first, and then this value is being divided by 5. So you could see the difference between how the operators are being evaluated, right? It's always from left to right if you have operators of same precedence. Okay, division and multiplication have same precedence, addition and subtraction have same precedence. Okay, so finally the thing that I want to show you is the modulo operator. So if you just want to get the reminder when you divide two numbers, let's say for example 7 divided by 2 is 3.5, but 7 modulo 2 is 1. This is because when you divide 7 by 2, the remainder is 1. That's what you get here. Okay, so simple. I think so far so good. So you could just have parentheses as well. 2 plus 5, oops, 2 plus 5 multiplied by 10. Okay, so you can see the difference between like the same numbers and same operators being used with and without parentheses. I think it's quite self-explanatory. Okay, so let's move ahead. So going ahead, next thing that I want to introduce is um, we see. Okay, so let's just do the floating point number. So now what we saw was integer type numbers. So how we could test a given particular object's type is through the type inbuilt function. So you just do like type of 1, it's going to be return int. Okay, that means the object that you have entered or given to the type function is an integer. That's what it says. Okay, so type of 3 into 3 is 9, which is like an integer. Okay, so the other type when you handle numbers is the floating point number. 3.4 is a floating point number, so you could just find its type same way. Okay, three type of 3.4 is again floating point number. Okay, I think it's quite simple to understand. The same operations that we did above applies to this floating point number as well. Okay, so the other type of numbers in Python that you could see is the complex number. Okay, complex number in Python is being generated by you enter the real part and then like minus, let's say, then 5. So generally you might have been used to this convention of I, but in Python it's J, not I. Okay, so this is a complex number. So again, you can just find its type. Okay, quite simple. So now you could just kind of like see is that sometimes you want to use a value in some other place, or let's say you are doing a complex computation. So that means like you might want to use the same value in a repeated fashion, or like change its value over time. Okay, so this is where the concept of variable comes into place. Okay, you store your value into a particular place and then use that particular reference in order for to compute in some other place. Okay, so variables is quite the same that you if you have learned other languages such as C or C++. Okay, it's almost same, but it's kind of like much more simpler in Python. Okay, if you have worked in C or C++, you might have to declare the variable before using it. But in Python, it's just kind of like a direct assignment. Okay, a equal to 4. That means I am assigning the value of 4 to the variable a. Okay, so simple. It's as simple as that. Okay, so now you could just do type of a. You could just see it's an integer because now a represents 4. Okay, so simple, right? So if I could have another variable like 23.3, and then I could just do all the operations that I did above. Okay, so I could just do a plus b, a minus b, a multiplied by b, etc., etc. Okay, so simple. So this is why you want to use variables to store results in a particular point and then use that particular reference in order for further computations. Okay, quite simple. But the thing here is about variable, how do you name it? Okay, so randomly naming A, B, C, or like some XYZ is not going to make sense. Okay, you should make sense of your variable name. So one of the main characteristics of a good programmer is that he should know how to properly name variables. Okay, so there are various ways in which you could learn this. There is something called as pep8. Okay, so if you just type in pep8, you should see this particular thing, pep8 style guide for Python code. So here they just kind of like give you uh, an overall idea of how you should name a variable name, how you should name a function name, how you should do a class name, etc., etc. Okay, so this is, I would recommend you going through this so that like you follow the maybe the uniform standard thing. Okay, so that like the readability of your code is much more higher, because if you write a code, if you are the only person using it, then it's totally fine. But even let's say for example you write a code and you come back after 3 months and you open your code, the chances of you not understanding is higher as well, right? So but if you name your variables properly and have proper commands in your code, then I think it should be fine. Okay, this is the reason why you should name your variables properly. So let's say for example, I'll just show you how I name my variables. Let's say for example, I am trying to add uh, my age with my friend's age. Okay, so the way I would name is my age, let's say 24. Okay, I just ran it. So now like whatever computation I want to do, I could just do. Okay, now this particular variable name makes much more sense, right? Okay, my underscore age means like, okay, this particular variable is representing the value of age. Okay, I could have just named it like, so now it doesn't make sense at all. Let's say, for example, you're reading this code right now, and then like, what does this particular thing mean? Okay, that's the thing every people feel, right? So this is the primary reason why you want to get your variable name Spartan. Okay. So the other thing that I follow as a convention when I name a variable is I would just append the type of the variable at the end. Let's say, for example, uh, if I want to kind of like create a variable name for my salary, okay, so salary float, okay, okay, this is how I would name it. Now it shows me that, okay, so this particular number corresponds to salary and then it's of type float. So the reason why I do this way is because it's much more easier for me to kind of like build complex code. So that's the reason I follow this particular convention. Okay, so I would ask you to try the same way. If it works for you, totally good. If it doesn't, still you could just follow the PEP 8 convention, I think, which is still good. Okay. So other thing is like how do you name your variable? So just make sure like you always start with um any character, not numbers, and then like no special characters allowed, underscore is allowed. Okay, all those convention like when you read the pep style guide, I think you should have all those instructions right there as well. So let's just move ahead. So we saw about like basic operators in Python, and then like how do we name variables, right? So now going ahead, we'll see about Boolean operators. Okay, so I'll just do an heading Boolean. So Boolean is nothing but true or false, so simple. Okay, so nothing more than that. You could just think kind of like a true or false, one or zero, yes or no, in or out, all those kind of binary things that you could imagine. Okay, so in Python, you could just do like true and false. These are the Boolean values. Okay, so you could just try again with the type command. So type true is going to give you bool. So type false again bool. Okay, so simple, right? So the thing that I want you to remember is in Python, all objects are considered as true, okay, except empty objects. Like when you consider integers, zero is kind of like empty, right? So zero corresponds to false in terms of Boolean. All other numbers, okay, whether it might be positive or negative, corresponds to true. Okay, just remember this. So 0 corresponds to false because it's empty, right? So similarly, empty strings, empty list, empty tuple, empty dictionary, empty set, okay, all corresponds to false in terms of Boolean. All other non-empty things corresponds to true in terms of Boolean. Okay, just remember this because it's so important. Okay. So going ahead, we'll just do a few uh, operators, few other comparison operators. So if you want to compare two values, so 2 greater than 3 is false. Okay, so you're just trying to compare a particular object with another object by checking whether one object is greater than the other. Okay, this is called the greater than operator. I think like most of you seeing this like would know this, but as I say, like still I want to do this. Okay, so this is less than operator, and then you check for equality here, and then you check for non-equality. Okay, so as you could see, like when you assign a variable, you just used a single equal to. When you use double equal to, it's kind of like comparing whether two objects are equal. Okay, so understand the difference. So a single equal to corresponds to assigning a particular value to another value. A double equal to corresponds to checking whether both of these objects are equal or not. Okay, quite simple, right? So now, as we saw, like we just wrote so many commands, comparing them, understanding the type of object. but it would be nice like if we could keep track of the documentation part as well. So like whatever we are doing right now is so simple, so it doesn't really matter. But when we start writing complex code, I think each line matters. Okay, so that's why you need to use comments. Okay, so comment is nothing but you just do like hashtag space and then like write whatever you think about that particular statement that you have written. So I just write like comparing 2 and 3. Okay, so this is just a command. Okay, so Python interpreter doesn't execute this one. This is just for kind of like a documentation purpose. So this is how we do it. This is how we write commands. Comparing 3, 2. Okay, so I would really recommend you to start using comments. If you are new to Python, make sure like even if you write the simplest of statements, do comments. Okay, this is because like later part of your programming life or Python life, it's going to really help, especially when we do machine learning algorithms and through Python. I'm sure like it will be really useful. So it might sound silly like recommending comments, but it makes more sense. Kind of like it really helps. Okay, so please make sure that you write comments in your code. So that's the thing that I want to say here. So apart from this, we saw basic operators. We just saw how to compare two objects. You could obviously extend this to several objects as well. Like you just do like 4 greater than 6, less than 3. So you could just extend this to many objects as you want. Okay, so in this case we have like 3 objects, like we are just comparing 4 greater than 6 and 6 less than 3. Okay, so what actually happening here is like it's just comparing 4 greater than 6. Okay, so now this is false. Okay, and then like 6 less than 3. Okay, so again this is false. Okay, so now it's kind of like false and false makes false. Okay, so that's how the computation is happening right here. So if we just do like 4 less than 10, 10 less than 10 greater than this 4, so it's true. It's because like 4 less than 10, this is true, and then 10 greater than 4, that is true again. So that's why it's written false. Oh, sorry, true. Okay, so I think you have an understanding of how the comparison operator works as well. So finally, what I want to do is like the Boolean operators. Okay, so the and, or, and not. So these are the Boolean operators that we have in Python: and, or, and not. Okay, so it just works the same way like how a AND gate or gate or NOT gate works. Okay, so you just feed into Boolean operators as input, and then it computes based on the truth table and then returns the output. So let's say for example 5 greater than 2 and 5 less than 3. So it's false because 4 greater than 2 is true. Okay, so now this part is true, and 5 less than 3, that's false. So true and false returns false. So that's why you have false here. So now if you just see this particular block of code that I wrote here and this one, okay, so you could just write this one using the AND operator as well. Okay, so what we have here is 4 greater than 6 and 6 less than 3. Okay, so this is equivalent to this. Okay, so that's how the computation happens. So Python compares this and then compare this and then uses AND to compute the final result. Okay, so more simplified or more understandable way of that thing to return is in this form. Okay, so I hope it's clear now. So similarly, next one is OR table. So 4 greater than 3 and 3 less than 1. So this is true because 4 greater than 3 is true, or 3 less than 1 is false. right? So true or false is always true. So you could just see the truth table. So you could just type in and truth table, and then let me do this. Okay, so you have an image. Okay, inputs A and B. So you could technically consider 0 as false and 1 as true. Okay, so when you input 1 and 0, the AND gate always returns 0. Okay, so the AND gate returns 1 only when both the inputs are 1 or true. Okay, so the OR gate returns 0 only when both the outputs are 0. In all other cases, it returns 1. So the other gate that we want to see is the NOT gate. So we don't have the NOT gate here. So the NOT gate takes only one input, and then like it returns the complement or the opposite of the input. Let's say, for example, not true is going to give false, because not of true is false, right? So not false is going to return true. Okay, just the opposite. Okay, so simple, right? So in this case, the Boolean operator, the precedence is not has the highest precedence, followed by and, followed by R. Okay, so whenever you have a code, not is executed first, and then and then R. So let me just show you a quick example for that. Okay, so 3 greater than 2, oops, then 4 equal to 5, or 3 greater than 3. So here we have false as the output. So this is because the AND is executed first. So 3 greater than 2 is true, and 4 equal to 5 is false. So this term becomes totally false now. So false or 3 greater than 3 is false again. So false or 0 according to our table is false. So that's why we have false. So let me now just exchange the and or in this command. So no, let me do this. 5 or 3 greater than 1. So in this case, again, we have 3 greater than true, which is going to be true, and this is going to be false. So this is again false, right? Okay, so and then finally we just compare 3 greater than 1. So false or true is true. That's why we have true here. So now let me just do an example where OR comes first, followed by AND. So if I just do the same example, 3 greater than 2 is true. So what I do is 3 greater than 2 or 4 equal to 5, and 3 greater than 3. We make this 4 greater than 3. Okay, so in this case we have the output true. So this is because again the AND is executed first, not the OR. Okay, so 4 equal to 5 is false, and then this is again true now. So false and true is false. So here we have the value true. So true or false is true. Okay, so I just want to show you an example where you could just do using parentheses. If you want a particular thing to be executed first, what you just do is like have them in a parentheses so that they are being executed first, not the other way around, or just following the precedence rule. Okay, so now in this case the parentheses executed first, okay, and then followed by this thing on the outer side. Okay, so simple to learn, just keep this in mind. Okay, so we just saw the Boolean operators as well, and then all the operators in Python. Okay, so the other thing that I want to say is, like, since I say Boolean is kind of like equivalent to 0 and 1, that is false and true, I just want to show you. So you could do these kind of things in Python. So true plus true is going to be true. It's going to be 2, sorry. This is because true is equivalent of 1. Okay, so 2 multiplied by 21 is 21, because now we are just kind of like multiplying 1 with 21, so it is equivalent of that. So similarly with false is 0, because 0 multiplied by anything is 0. Okay, it's the same logic. Just remember this, it's so important. Okay, so with that, I think we just saw like the introduction to Python, very basic introduction. I think like as we proceed with further videos, like when we get into strings and lists and tuples, I think I'll be able to get into much more complex details of Python, like even with respect to integers that we saw. We need to see like various methods available in integers, like you have an integer 23, so you could just do these kind of method operators as well, which we will look later. Okay, so finally I just want to wrap up this video by telling about the magic methods available in IPython. So the magic methods are something like that follows this particular symbol, so percentage, and then some commands that we will enter, or double percentage, some commands. Okay, anything followed by a single percent command means like a percent symbol means like a line magic. So anything that follows double percent means a cell magic. That means the whole cell, because like in a cell you could just write either a single line code or multiple line code, right? So that's the difference. Okay, so if you have multiple line codes, you just need to make sure you have double percent sign. Okay, so before going ahead, like if you are kind of like stuck in IPython, if you want to learn about any particular thing, you just do the question mark symbol and then execute it. Okay, so you just see what are the things available. It's kind of like a help documentation that you get. Okay, so we will cover like let's say for example these things. We will see these things when we see options. Okay, there is other thing called as like a so I can kind of like provide a documentation. What are the various things available? What are the various magic methods available? So all you see here, send something. All these are magic methods that are available in IPython notebook. Okay. So and then, for example, you need to know a particular thing about an object. So you just do like A. So now A is 20. So you just do A question mark and then like shift tab in order to have an understanding about this particular object. Okay, right. So these are the various things that you could do with IPython. So other things like opening a file, making a copy, downloading a file, same thing that you would see in any other softwares. Okay, so this is self-explanatory, I think. Okay, so how to insert a cell, how to move up a cell, just help a cell, copying a cell, all those stuff, and then just do all these things here. Also, like you could just do the same thing above using keyboard shortcuts as well. Let's say, for example, if I want to generate, oops, yes. So if I want to create a new cell below the existing one, I just type B. Okay. So now I have a new cell. So if I want to create a cell above the existing one, I just do like A. So it creates a cell above the existing cell. So if I want to run an existing cell, you just do Control Enter. Okay, so there are many shortcuts in which you could perform these kind of activities as well. I would recommend you to learn those as well. It's going to be really, really useful when you do complex computation with the IPython notebook. Okay, all are so simple to learn. I would say like practice, practice, practice. Okay, so nothing is possible if you practice. Okay, so Python is so easy to learn. I'm sure like most of you would have felt like, is this Python, or like, is it so simple? Yes, Python is really, really simple, but the thing it can confuse us when you learn like, let's say for example, when you learn list and tuples, you might get confused whether like which to use where, or like when to use what, all those kind of stuffs. But once you have a clarity of those sorts of things, I think like it's a really, really useful program. Okay, easy program as well. So let's get with the magic method. So let me show you. Uh, okay, let me just show you how to write a JavaScript code. Okay, so you just do like double percent symbol and then like JavaScript. So now I have made this particular. Sorry, no space. Okay, so it just says like JavaScript to cell magic, but the cell body is empty because I haven't written any JavaScript code yet. So let me just do a JavaScript code quickly. Okay, so now this is just a JavaScript code. So once you run it, it just kind of like makes it that way. Okay. Oops, I think we lost track. No. Okay, so you just saw like how to write a JavaScript code through IPython notebook as well. Okay, so similarly, you just do HTML, all those kind of crazy stuffs as well. So also like you could just time it, like how much time it's taking for your code to run. Okay, so this particular thing called time it is another magic command. Okay, so I'm just kind of like running a loop. Okay, running a simple for loop. Okay, so it's just gonna show me like how much time it took in order for it to execute. So you could see like it took me this many seconds per loop. Okay, so you could do all those kinds of stuff, and then you could just, let's say for example, see the history of all the commands that you have typed in. So %tree, so line command, line cell magic, line magic, that gives you all the commands that you have typed so far. Okay, this would be a good way to store, let's say if you want to store all the commands that you executed. So this is the way you just type it, copy and paste it in a notebook, notepad file, and save it. Okay, so similarly there are so many other things that you could do. Okay, so just an underscore corresponds to the previous output that we got, which is 23 if you look back. Okay, 8 to 23, so this is what we got. That's the latest output that we have, right? So similarly, like if you do like a double percent, it's going to show me the previous output. You could go max of 3 underscores, not more than that. Okay, so and apart from that, as I say, there are several things with respect to the IPython notebook. I will explain those things as we use IPython further. You could debug your code in IPython. You could do much more things like create graphs through IPython as well. So many other steps. So let's get started. So the real game starts with Python. I think like once we enter list our tuples as well. Okay, so thank you guys. Oh, final thing I just want to say, like final feature of IPython notebook. So if you just do an exclamation and then like type whatever, it's going to consider it as a system command. So exclamation of ls is going to return me what are the files available in this particular directory, right? So that's the ls command. So I have like Python, week1, ipynb, and test.py. So these are the files that I have in this folder. So that's what we have here. So similarly, you could do all crazy commands, system commands, when you have like the exclamation mark at the front. Okay, so that's it for this video. I don't want to make it much more complex, so I would recommend you guys to practice a lot. Just play around with these notebooks, interactive mode and the scripting mode. Okay, so next video we'll see about strings and what are the various way to represent your code. Like we need to see like the print statement, how to get an input from the user, and as we progress we will see like much more complex commands in IPython as well. So if you have any questions, leave them below in the comments. I'll make sure I answer it. If you want to contact me, just email me. I'll make sure like I answer emails. If you have any other stuff to say, just use the commands as I said. So if you like the video, give a thumbs up. If you don't like it, just don't give a thumbs up. Okay, and then like subscribe to the channel Velvi. Thank you guys. See you in the next video. Goodbye.